A short video about Z-Wave security version 2. So to get started, first you need to download the source code of the Z-Wave stack. It's on GitHub, but you need to be a Z-Wave Alliance member to get access to it. The code of s2v2 is not yet merged in mainline, so you need to download a branch, which is based on earlier version, but the review is ongoing, so we hope it will be in mainline soon. So following the instruction, you have to rebuild the application using real-time mode release for Linux. Then run cmake real-time presets to build this application that can be used to simulate a Z-Wave network. And we are packaging Z-Wave stack binaries into a single folder that we use for our ZPC gateway software. The Z-Wave network is running locally on Linux, and we use a sniffer tool to capture the world traffic. It's an application for Windows, but you can run it on Linux using Wine and run this bridge. And then you can set up a device that will act as a capture device, and then you can start selecting the network. At the moment there is no traffic because there is no device running yet. But let's keep it running. To generate Z-Wave traffic with a sample app we just built, we need to add one piece to the puzzle. This is the z-wave-protocol-controller from Silicon Labs. It's a gateway software, but here we are using it some automation to show the s2v2 in action. It can be used for various test cases and eventually some CI run too. Looking at the instruction, with the helper command you can download all the dependencies and build the ZPC application for Linux. So currently it's depending on Unify SDK, which was previously presented. So ZPC is basically a high-level API to control the Z-Wave network using MQTT. And we have this demo script that run different applications and we can interact them together. So let's get started with the device inclusion. We are adding a switch to the network, and the automation is finding the host controller. Then you look at the node home ID, controller home ID, think it's different. Now it should add some inclusion, so it toggles the switch to learn mode, and then we can start the add mode command and it will connect to the system. To enable the S2 security layer, we are adding the node device security key first digit, as known as the security code. And then the device should be included. Let's verify by looking at sniffer traffic. It has S2 encapsulation, so this means it needs a network security key. We will decrypt it after testing the network layer security, NLS. So let's use enable NLS command on the switch and check from the ZPC shell if the NLS is supported. And then we can run some network command like discover neighbor on node 2 and remove the node. Meanwhile, sniffer captured a lot of frames, still encrypted, see S2 message encapsulation, and we need the network key to decrypt them. So from ZPC shell we have the network key S2 authenticated. Let's get into the first spam frame, use the decrypt feature, ignore the error, and then the traffic should appear in clear. Scroll down, all you see S2MEM message are decrypted. So we can look for what we are searching, these NLS commands, as you see a set, then a get that triggers a report. So this is a Z-wave equivalent to the MQTT command. And then we can look for get node in range, which was a discover neighbor. So that's it, and thank you very much for watching.